A combination logic circuit is where you have multiple inputs and depending on whether some kind of function you use, you get one or more outputs. Now there are different kinds of combination logic circuit, like the decoders, encoders, multiple demultiplication. So let's go in detail. So a decoder is a type of circuit that takes in a number in an unsigned binary form and generates a 1 or a high in the output line that corresponds to the input number. All other output lines are set to be 0 or low. So what does this mean is, at most, you could have only one. Everything has to be 0. So here's an example of a 2x4 decoder. If you have a 2x4, this first number shows you how many inputs are there, and the second number is how many outputs. So you have input A and B, and that goes to output D0, D1, D2, and D3. And now let's do the truth table for that. So here A0, 0, and at A0, 0 you get 1 for D0 and everything is a 0. When it's 0, 1, you get 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, and when they're both 1, you get 0, 0, 0, 1. As you can see, if I'm looking at this from D0 to D3, the numbers fall along the ones falls along the diagonal line. Okay. So, and each of these, depending on what is the input value, you have a Boolean expression. So D0 is going to be, they're both zeros, so not A and not B. For D1 is, since your value for B is 1, not A, B. For the third one, D2, you have A and not B because 0 is the value for B. And for D3 is AB because they both are 1. Okay. Here's another way to look at it. So you have A0 and you have this. So this is a top-down, just a block diagram. This is the actual circuit diagram. You have two inputs, A0, A1. You have D0, D1, D2, D3, and you have two inputs and four outputs. And you have the Boolean or min-term equation over here on the truth table. Just like you have 2x4, you got 3x8. 3 inputs, A0, A1, A2, and 8 outputs, D0 to D7. And as you can see, you write in A2, A1, 0, you have on the diagonals, you have 1 based on the value of this. So if I'm looking at my D0, the Boolean will be not A2, not A1, not A0 because A0, and you continue like this. And there is actually going to flip-flop between the values of this. So D1 is going to be not A2, not A1, A1. Then you have not A2, A1, not A0. Then you have not A2, A1, and A0. And you go like that. Here's the other way to look at it. 3 inputs, 8 outputs. Now the way to you can mathematically calculate is, if it's a decoder, you have n inputs and 2 to the n outputs. Okay, n input, 2 to the n output. So a decoder is a n to the 2 to the n. Okay. Now you have decoders, then you have the other side, a encoder. An encoder is a type of circuit with two to the input lines, but only one of which can be high at any given time, and produce a n-bit unsigned binary number that corresponds to the raised input line. So you have 4 inputs over here, but 2 outputs. That's why it's a 4 to the Q encoder. So D0, D3, D2, D1, D0 are your inputs, and your Q0, Q1 as your output. So when everything is 0, it doesn't work. You actually ignore it. When you have 0, 0, 0, 1, that give you not Q1 or not Q0, and you could look at the expression of this. In a encoder, the D0 does not matter. So the expression Q0 is derived from D1 or D3. So 0, 0, that will give you 0 for Q1, and D2 is Q1 is D2 and D3, or D2 or D3. So 0. So these will be both zeros. So now look over here. For Q0 is D1, D1 or D3. D1 is 1. D3 is 0. This will give you 1. And this will give you 0. And you fill it out with the rest. Okay. So to a 4 by 2, you have a 8 by 3. Same exact way. Okay, so in an encoder you have 2 to the inputs and n outputs. So if you have 64 inputs, then you have 6 output. The other one is called multiplexer. Okay, they are circuits that are used to transfer circuits that are used to transfer the contents of an input data line to an output line based on the value for one or more inputs that are matched. So in other words, it is a if condition or some kind of decision making. You have 2 inputs over here, and you have 1 input and you have 1 selector line. So compared to encoder and decoder, you have an extra thing. You have something like S, which is a selector, inputs, and Y. Okay, so right here is a 2 to the 1. So S, D0, D1, and the output D0 and S0 and D1 and S, and that will give you Y. You could have 2 to the 1, you could have 4 to the 1, 4 by 1, same thing, but only difference is in this case you have 2 SR plans. Now, what are the application multiplexers? They're used in communication systems, they're used in television and radio signals, also in the computer, in memory addressing, and IP protocols. Like here, another example is you have different sources of music coming in or sound coming in. You could use a multiplexer depending on what you want to choose and to send you a single sound system. Similar to multiplexers, you have the opposite, demultiplexer, which has single data input line and selected input lines and 2 to the output data lines. So right here you have A as your input, S1 and 0 as your selector lines, and 4 output lines. the input will show up in the output depending on where the S1 and the search line is. I hope this will help you understand about combination logic circuit.